Let's begin our multicast discussion by understanding the benefit of multicast, and I think I can explain that best by comparing multicasting with unicasting and broadcasting. Consider this scenario. Let's imagine that we have a video server and it's going to be streaming out some corporate announcement later today, and it's going to go out to the different employees that have time to join that announcement. And just for simplicity, let's imagine we have 3 PCs, but it might be 300 PCs. But let's imagine we have 3 PCs, and 2 of those PCs, they want to tune in and they want to receive that video stream. PC 3, that person is busy, they'll catch the replay, they do not want to receive the stream. Well, the question is, how can I send traffic from the video server just to those recipients that want to receive the video? Well, one option is to use unicast. And unicast is one-to-one communication. I'm going from one IP address to another IP address. And in this case, if I want to send this video stream to PC1 and PC2, I'm going to be sending duplicate traffic to PC1 and PC2. So for every video packet that gets sent out, I send a duplicate packet to PC2. Now, this is only 2 PCs, but if it were 200 PCs, I would be sending 200 copies of every single video frame. That could put a load on the video server. It could put a load on the bandwidth between the video server and switch SW1. It's just not scalable for this particular scenario. Another approach to get traffic out to these PCs is to use broadcast. And broadcast is called one-to-all communication, where all means all members of a subnet, of a broadcast domain, or of a VLAN. And in this case, that would ease the load on the video server. It would only have to send out 1 copy of every video packet, and it would go everywhere within this subnet. Well, the good news is we eased the load on the video server. We eased the bandwidth demand on that link between the video server and SW1, and both PCs 1 and 2 got the video. The downside, though, is PC 3 that did not want the video, they also got the video. And that PC is going to have to take time out of its day to say, oh, this packet is not for me, discard. This is not for me, discard. It's not going to be efficient for those devices that do not want to receive the stream. Well, this would be a great application for multicast. Multicast is one-to-many communication, where many refers to the members of a multicast group. Specifically, what we can do is have the PCs that want to receive the traffic, they can join a group. And with IP version 4, that group is defined with a Class D IP address. In other words, that first octet in the IP address is in the range of 224 through 239. And in this case, let's say that that multicast group has an IP address of 239.1.1.1. And it's important to understand that this Class D IP address, it's always the destination. It's the name of a group. You're never going to have a device whose IP address is a Class D address. It's always the destination. It's the group address. Now, in this case, the video server is going to send out traffic destined for 239.1.1.1, and the switch, through something called IGMP snooping that we'll discuss a bit later, it knows that only PCs 1 and 2 want to receive that traffic, so switch SW1 will only send copies out to those PCs. PC 3 does not get a copy of the traffic. So this is really the best of both worlds for this particular scenario. And there are certainly times when broadcast would be appropriate or unicast would be appropriate, but here multicast is a great fit, because we've eased the processor burden on the video server, we've eased the bandwidth demand between the video server and switch SW1, and only the recipients that want to receive the traffic do receive the traffic. And to sum up these different traffic flows, we said unicast was one-to-one communication, broadcast was one-to-all communication, all members of a subnet, and multicast is one-to-many communication, where many refers to the members of a multicast group.